Okay, hello everyone. Welcome back to another data analysis video. Still focusing on data visualization, visualizing variables and data. In this video, I'm going to demonstrate how to create visualizations of data using Seaborn's jointplot method. So the jointplot is quite useful in that it allows you to plot the relationship between variables, so bivariate relationship between variables, as well as plot the individual distribution of a variable all in a single plot. Okay, so we'll see what that means in a second. But first of all, I'm obviously working in Python as normal and using Jupyter Notebook. But first of all, I'm going to import some libraries, software libraries that might be useful. I'm importing pandas as PD, numpy as np, matplotlib.pyplot as plt. And I'm importing seaborn as SNS. So we're going to, basically the plots we're going to create in this video are going to be seaborn plots. So let me just run that cell. But I'm importing numpy and pandas as well in case we need them. I'm going to use pandas to import the data set. So the data I'm going to use is something I got it saved on my laptop. I'm not sure if it was data that was kind of made up or simulated by one of my colleagues just for teaching purposes, and it's data that relates to exam anxiety. So I've got it saved as a CSV file called examanxiety.csv in a folder on my computer. I'm going to read that in, import that using the pandas pd.read_csv method. I'm going to save it as an object called exam, and if I run this cell, that will import the data and show us the header, the first 5 lines of data. So we've got a few variables here. We're only interested in some of these. Code, I think, is just a participant ID number. Revise is kind of how much time someone spent revising. Exam is their exam score. Anxiety is some sort of anxiety level score. And sex, 1 and 2. So dummy coded sex, sort of one could be male, 2 could be female. I'm not sure which way around. Doesn't matter too much, just for the purpose of this video, just to illustrate how to create joint plots. So to start with, I'm just going to create a basic joint plot, and what I'm going to do is I'm going to use the revise variable as the x-axis variable and exam score as the y-axis variable. Okay, so let me run that here, and what you'll see, so this is a seaborn joint plot. So what it's done is it's created a scatter plot of the relationship between the revise variable and the exam score variable. So we can see those data points there, and then it's also created marginal histograms showing the distribution of these variables individually. So if we look at the y-axis here for exam score, this histogram opposite it, directly opposite, this is the distribution of exam scores. Okay, and if we look at the revise on the x-axis, the one directly opposite it is this histogram here is showing the distribution of scores for revision. So lots of people have done a couple of hours revision, very few have done a lot of hours revision. Okay, so that is a really basic seaborn joint plot, and the way I called it is I specified exam.revise. So I called the data frame, pandas data frame object, using this dot method to specify which of the variables I wanted, and then for the y variable exam spelled exactly as it is in the data frame with a capital letter at the start of the variable name. Another way I could have done this, you've seen this a few times now I think, is I could have basically just passed the names of the variables as strings contained within quotes, single or double quotes, doesn't matter, and then specified the data frame to be the exam data frame. And this, if I run this, you can see the slight differences in the code between this syntax here and this one here, but it produces exactly the same plot. So you can see there we've got our bivariate scatter plot, and then we've got the univariate histograms showing the distribution of the variables. So the default is for the joint plot is scatter plot for the relationship between the two variables and histogram to show the distributions. But there are 6 different kinds of plot that you can create using the joint plot method. So like I said, the default is scatter, but you can also specify KDEs, so kernel density estimators, which show a smoothed out version of the kind of distribution. Histograms, hex plots, reg plots, and residual plots. You can use any of those, and to do so, you just have to use this kind argument. So you can see here I've added. So this was the original bit of syntax we used there to create the plot above, and then I've just specified this extra parameter here, this extra argument, kind equals, and I've asked for a KDE plot within single quotes. So if I run that, what you'll see is we now have a bivariate KDE for the relationship data rather than a scatter plot, and we have like univariate KDEs, so KDE individually for the distribution of each of the variables there. So I like KDE plots as a means of inspecting distributions, and as you've seen before, look at this. Each of these levels, circles, represents the same height, frequency, density, whatever you want to think of it as. The closer they are together, the more of a peak. So we're like looking down on top of a hill on this bivariate plot here. This is kind of the top of the hill, showing the density, the joint distribution of those two variables. Okay, so I'll demonstrate another really useful one, I think. So that's the KDE one there, and like I said above, we've got all these other options. But one that I think is very useful is the reg plot. So if we specify the kind argument using reg in single quotes, this will give us a combination of different plots. It gives us quite a lot of information. If I run that, so you can see now what it's done is it's plotted the default kind of scatter and histogram for the marginal distributions, but it's also fitted the regression line with these bootstrapped confidence intervals shaded around it, and it's overlaid the KDE, the kernel density estimator of the variables distribution on top of the histogram. So that, I think that's a really useful one. That gives you it's effectively giving you 4 different plots in one. Okay, so one thing we can do is we can add additional elements. So like with most things in Python, it's obviously object-oriented programming. So we could save this plot, the sns.jointplot that we've been created, this basic one, as a specific object by assigning it to some sort of object name. I've just used JP here just for initials for joint plot. So I've set the initial joint plot we created, where we're just looking at revise plotted against exam scores, and I've created this object called JP. And then what I've done is I've in this line underneath, I've used the .plot_joint method. So I've done jp.plot_joint, and in parentheses, I've passed it is to create a KDE plot, make the color gray, and 5 levels. So display 5 levels of density for the KDE plot. Remember that the more levels you ask for, the more close together the levels of the KDE plot, the bivariate, the joint distribution KDE plot will be. If I run that, you can see now we've got our basic grid, our scatter plot with our histogram, and I've overlaid with the second line of code here in grey in colour these 5 KDE lines essentially. Okay, so yeah, that's sorry, it's actually 4 KDE lines. So remember 0 index, so 0 to 4 KDE lines on that plot. Okay, yeah, so we could add additional elements, and I guess we could also ask We could also put, like we wanted, a regression line applied on there as well. Putting too many things on it starts to look a little bit messy. Okay, so as you've seen previously with seaborn plots, we can also plot, we can use the hue argument to plot a categorical variable. So there's one categorical variable in this data set, which is sex, coded as 1 and 2. What I'll do is I'll create that basic joint plot, but this time we will kind of separate the data into sex, group 1 or group 2, using the hue argument. So it'll separate them out using different colors. And what you can see there, so by default, I guess it's chosen a palette, it's chosen colors that it thinks are the most useful to represent the data that we have. You can see there's an awful lot of overlap between the two variables, and I personally don't think that's that easy to look at. I don't think the colors are great. The palette that's been used here is fantastic. But there's obviously a lot of overlap in terms of revision score between the sexes and in terms of exam score. There's slight differences. You can see like the distribution for group 1 could be male, could be female. I'm not sure exactly. Didn't put labels on the data. But we could improve this plot by maybe playing around with setting the aesthetics differently, and we can change the color of those two groups. So we're still going to ask for use sex as the hue argument, but we can also use palettes, and we can set different palettes. Here I've used one called seismic. So any palette that's available in matplotlib we can use as an argument in seaborn here. And I think there's over 100. So to find out what the different ones are, I just kind of looked this up on the matplotlib documentation to find out what the different ones are and which ones might be most useful to present your data. You can just look at the matplotlib website and the documentation that's available. So seismic, sort of a red-blue contrast. So that's a little bit better, I think. It's sort of they're quite dark colours, but it makes it easier to differentiate between these two. So there's huge overlap between these two groups. If they were really separated out, it would be kind of much easier to see. But with the data set I've chosen, that's not the case. So let's try one more. So I've chosen a palette called Autumn, and that's kind of lighter colours. Yeah, maybe a bit garish, but you can see it's kind of lots of options there. Anyway, so last thing I'll demonstrate is there are lots of things you can change. There are lots of different keyword arguments you can use for the marginal keywords or for the scatter keywords, and you can take anything that you can use in matplotlib for plotting using a dictionary. There are other things you can do to change the size and the width, the height and width of these plots. I'm not going to demonstrate all of them because this will make this a very long video. But as I've said before, check out the seaborn documentation. You'll be able to see all the different things you can do to customize these sorts of plots. But the last thing I will demonstrate is kind of the ratio argument. So ratio specifies the ratio with this main plot here to the size of the marginal plots, and the default is 5:1. So this is kind of 5 to 1 bigger than the marginal plots, the relationship plots. And here what I have done here is I've used the ratio argument and I've reduced it, I've changed it to 2. So what this has done is I've changed it from 5:1, the default, to 2:1. And what this does, if I run that, is it makes those marginal plots bigger in relation to the actual scatter, the bivariate relationship plot showing the scatter on it. So it's kind of just a case of preference, really. There are lots of other things you can do. If you notice here, here's the top of the scatter plot, and you've got a gap before the marginal plots. Same here, it ends here, and you've got this gap. You can change this. There are arguments you can use to change that, so it kind of sits flush along the edges. The marginal plots sit flush along the edges. All sorts of things you can change. But the purpose of this video is just to kind of demonstrate how to create these, some of the things you can do with them. and the kind of how versatile they are for plotting kind of individual distributions for data, but also the relationship between variables. Okay, hopefully that was useful.